All right, for this last part of Unit 1 has got 3 parts because you need all 3 of these parts to do your assignment tracker, but they're really 3 different. Guys ready? There's really 3 different components that you need. There are 3 different topics. There's text files, which are not necessarily related to creating your own classes, which are not necessarily related to standard dialog boxes. But we need all 3, and that's why there's 3 parts to this unit in one assignment. All 3 of those are going to come together to create your assignment tracker. So now we're going to download the Pizza Shop order. After you've downloaded that, unzipped it, it will look like this. Welcome to my Pizza Shop. Very similar to our sub shop, very similar to your Belt's ice cream. We make selections and we create a pizza order and we find out how much it's going to cost. This example is going to carry us pretty much through the rest of the class. So we're going to keep building this thing and building it and building it. Initially in this unit, it's going to be as stupid as it was last unit, except for one thing. It's going to have a class associated with it, a custom class that we're going to build. Then in Unit 2, we're going to make it validate all those entries to make sure they're good. Tied to the RDD class, we're going to learn how to validate. These are fields. Ultimately, those will be fields in a database table someplace. We want to make sure in our GUI that the data we're accepting in those fields is valid. So we're going to add that. Then we're going to store all that stuff in a database. And we're going to allow the user to edit records, delete records. And finally, we're going to generate some crystal reports, all based on this one program. It's just going to keep building and building and building. So that you get some practice, you'll do the assignment tracker. Then you'll do a little more building in the gas estimate program, and then you're going to start fresh in your DVD, car maintenance, personal project. You're going to start fresh to get all of that over and over and over again to get some practice with it. I believe, what have I written here? I forget what's built in. Button save doesn't do anything. Form load initializes the form, loads my combo box full of sodas. And whenever we click a radio button, it automatically sets my form level size variable. This is very similar to what you did last semester. All right. Some basic stuff, but it's going to change now. Where's all my calculations? Where's my savings? Where's all my the initialize the form and so on? All of that's going to be a little bit different. I'm going to start learning how to create user-defined, also called custom classes. As we said in the last recording, you've been using classes for quite a while now. Since the first button you put on your welcome screen, since the first form you created, you've been using classes. Microsoft Visual Studio gives us classes, predefined objects like forms, like buttons, like text boxes, like radio buttons, like dialog boxes, those are all GUI visual objects. They also give us other predefined classes like stream readers and the file class and dialog results, etc. All those are built in. You've been using them. But what if you want your own? What if you need your own? I'm sorry, before I get to your own, when you get your first job, that company will have developed probably a huge library of classes that they use on a regular basis. Just like in Visual Studio, I told you there's a file stream reader class. We have to learn how to use it. You have to learn how to use the Skyward, the Sentry, the Berkshire Hathaway classes to build your programs. That's part of your training. I can't teach you that because every one of those companies have a different set of classes. Occasionally, particularly if you're developing your own projects, you'll have to develop your own classes. How do we do that? Why do we do that? Let's back up to that. You might remember on my website, way down at the bottom, It was a description of the three-tier model, the three-tier architecture. As programs get bigger and bigger and bigger, they don't fit on one form anymore. We need to navigate from one form to another. When we implement a classic database structure with 5, 10, dozens of tables, how do you get your head around all that? Modularization. You decompose it, break it into parts. Those tables are a great start. When we write those programs, the best way, the most maintainable way to write those programs is to really compartmentalize them into three groups. The data. Right now, our data is a text file. What if we decide that for my little program that we just wrote, from now on, we don't want to read a text file, we want to read a database? The program I just wrote, I can pretty much start over. I got to gut all that stuff for saving and reading and writing out the files. I got to replace it all with data stuff. If we designed it right, we should be able to literally pull a lot of that stuff out without having to change the GUI, without having to change any of the code in the GUI. Ultimately, that's where we're going. There will be three tiers. A data class that stores our data and also allows us to communicate with that data. Usually it's a database. We'll add that in Unit 3. And a business class. This is the new component that we're going to add in this unit, and we're going to enhance it in the next unit. The business class has all the rules in it. Last semester in Unit 5, you learned to write validating routines so that when we left a field, you checked it to see if it was right, and all the rules were embedded inside that validating routine. As projects get bigger, that's not where they belong. The business class has all the rules. Is a string required? Is a numeric field required? Is there a range of values that are acceptable? Is there a list of values, cabins 1, 2, 3, 4, that are acceptable? And a couple of, is there a duplicate record? Ooh. And we'll talk about consistency check later. This is all validation. Notice all the validation, almost, is done in the business class. Because those are all rules. This is required, that's a rule. The range is 100 to 200, that's a rule. It goes into business class. That way I can change rules, add rules, modify rules, and never touch my form at all. I want to make my form prettier. Fine, I give it to somebody who's really good at making forms pretty. I don't have to change the business logic at all. It still functions exactly the same way, it just looks differently. By compartmentalizing this, I can also assign this to two people at the same time. Say, you make the pretty stuff, you do the forms. Make it beautiful. I need these things on it, but make it beautiful. Somebody else builds the rules. Notice that there is no direct connection between the GUI and the data. When we write code in Unit 3, the GUI, the form, will never request data directly. All data requests have to come through the business class for two reasons. If I'm sending new data to the database, I want the business class to check the rules to make sure they're right. Is this data acceptable? Does it have data integrity? Robert's question from the last class. This business class is going to do all that for us. If it does, then the business class says, here, data class, put this in the database. When we bring data in, we're also going to check it. Is this data valid? Because it could be that one of those rude users actually went into the database, typed something in manually. If they put it in wrong, my business class is going to catch it. Your business class is going to catch it and say, there's something wrong in the database. When I get that error message on the phone that says, we get this message, there's something wrong in the database. So put the phone down, slap your hand, then pick the phone back up again. Stay the heck out of my database. And what'd you do? And they go, well, we needed to check. Don't do that. But your program doesn't. Then tell me my program doesn't do it, and I'll change my program so that it does. I don't want my users playing in the database because it ruins my data integrity. Because all the data integrity rules are in here. They're not in the database. So this is where we're going. This comes in Unit 3. In this unit, we're going to start learning the basic structure of these business classes. basic stuff. Next unit, we'll add the validation. Questions so far? Okay. So I often call it the business class. It's another one of those things that's got 800 names. Problem domain, it solves the problem. I don't like that one. But it contains all the business logic. I call it the business class. Technically in programming, it's a user-defined, because you and I built it, class. It's not built into the language. It's a user-defined class. But realistically for us, its purpose is to define the business logic, the business class. How do I create one of these things? Like we did new forms, like we did bring in existing items. We're going to create a new item. We're going to add it to our project. So let's go do that. You don't write code. Use a button to add a new file. We're going to start having more and more files over here in the Solution Explorer. Our solution is going to be more than one form and Voker tools from now on. It's going to be more. So we have to add a new item. If you've incorporated My Tools, it's the second button on the toolbar. I don't know where it is on the default one. If you don't have the Voker configuration thing here, you might want to go get that later. You got to find this button. Kind of looks like a square with a star on it. If you drop that down, it's got 5 or 6 choices. Okay. We could add a class. That's the shortcut. Don't do that. Let's do it the long way just in case. I want to add a new item. When you add items, there are all kinds of items that you can add. Classes, forms, user controls, about screens, bitmap files, all kinds of stuff, most of which we're not going to touch in this class. We will be adding new forms. Kind of did it already with your welcome screen, except you brought in existing forms. But you can create a project with one form and then add another one later and then add another one later when you're ready. But we want to build a class. We need to give it a name. Notice it has a .cs extension down there at the bottom. If you take it off here, you're braver than I am, but I'm pretty sure C# will put it back. Visual Studio will put the .cs back. I'm going to leave that alone and just double click on, I guess I double click the whole thing. So I'll be brave today for a change. When I create my class file, we're giving the file a name. Remember all those headaches you ran through last semester where the form name was different than the form object name? And I said, don't do that. Now I'm going to break that rule. Okay. I'm going to create a class name. I'm going to give it a prefix, CLS, for class. This is a class. This contains the description of a class. The reason I put the prefix on is if I put the prefix on all of them, then over here in the Solution Explorer, they'll all be alphabetical. And all the classes will be grouped together and all the forms will be grouped together, and it makes it easy to find stuff, easier. So that's my logic. This class is going to be for a pizza order, so I'm going to shorten that to just CLS order. Oops, I'm sorry. Up here it says CLS pizza order. It's just a name that you're picking. What do you want to call this class? The CLS prefix is just for the file. I'm not going to put the .cs back on, so I'm just going to add that. If it fails, I'll let you know. Nope, they put it on there for me. There it is. What's in there? Not much. Just the standard stuff, and most of this we could probably delete. I found a button. I haven't been able to find it since. I found a button somewhere that says, only keep the using commands that I'm actually using. These are the ones you normally would want, is what Microsoft is telling me. How the heck do they know that I want link? I have never used link. Must be important because it's there on the default list, but I've never used it. But there's a button somewhere that takes all these extra ones out that you don't need, but they don't hurt much. They might slow your program down a smidge, but not much. A namespace. Again, the namespace here matches the namespace for my form. They're both in the same namespace, otherwise they can't communicate with each other. So that happened automatically. Notice it says pizza shop order. I thought we called this pizza order. We did. The file name is pizza order. Here's the actual class name. The namespace is an all-encompassing bubble that is everything in my project. That's the namespace. So this class is part of that namespace. If you decide to reuse this later, you have to adjust the namespace. It's beyond the scope of this class. We won't be reusing this. Now, I don't like the CLS on my class name. There's no CLS form class. There's no CLS button class, or just button, form, radio button. So let's take the CLS prefix off of the name after the class. Do that every single time. The file name has a CLS at the beginning, so I know it's a file full of class stuff. But the class name itself does not. Don't think we've used this anywhere else, so using this and doing it everywhere won't really help much, but you can do it to get rid of the red line if you wish. In between these curly brackets, we describe a pizza order. What's a pizza order? Well, that's what we get to figure out. Now, if we already had a database, I'd look in the database and say, what's a pizza order look like? It's got a date, and it's got maybe a customer reference, and it might have the crust type, and it might have the combo type, or whatever. All kinds of stuff. My notes are going to help us here. In the RDD class, we've been talking about, you got to have your database before you build this, or you've got to have the requirements before you start building forms. It's true. But I'm not ready to teach you how to communicate with a database yet. That's complicated. We'll save that for Unit 3. So for right now, we're going to get the requirements from me. And they will match the database when it comes later. Real world, you get the database first. Okay, what's a class look like and what's it for? So just a quick review. We did the add new item. We clicked on, I needed to get a new icon for that button because the image has changed in 2013. Then we clicked the class button. Remember, you could also just drop this down and immediately say add class, and you get the same effect. I think you can come over here and right click and say, not there, how about on the project up here, add class, or add existing new item. There's other ways to do it. I think the easiest way is to just drop this and say add a new item and go pick class. So there's all the other alternatives. And we removed the CLS from the class name. I added it to the file name. It's still there. That keeps all my classes together in the Solution Explorer. That's its only purpose. But it's a valuable purpose. The name of the class itself is pizza order. And now our job is to describe a pizza order. Here's some concepts. These user-defined classes have 4 parts. The first parts are members. You'll often see the word attributes. They correlate almost directly to fields. Oh my God. 3 terms, all meaning the same thing. Within the class, they're referred to as members. We got to use that terminology. So when you're talking to programmers and they say members, you know they're talking about something that's embedded inside of a class. Those members are just like variables. The date that the order was placed, the size that they ordered, whether they want pepperoni or not, Boolean property, whether they want stuffed crust or crust type, or whatever else we're going to put in here. Here's some examples. The date, first name, the last name of the customer, the size. These are just fields. They're usually those primitive types that I talked about in the last recording. Strings, doubles, integers. They don't have to be. They can be dates. Date is not a primitive type. It's built into most languages today, but it's not primitive. Very complicated. So we have members. Then we have properties. What properties allow us to do is provide access to those members. This is confusing. Provide access to those members from outside of the class. I'll explain why in a second. So for every member, there's a property that goes along with it. Now, properties we've seen, right? Everything on a form, all that stuff we put on forms have properties. This combo box has all these properties. We get to define our own properties. What you don't see when you look at a combo box is that behind the scenes, hidden from us, are members that keep track of all kinds of stuff. many of them related to these. So in our class, we are also going to add properties. I'm going to show you how to do all this stuff. Then we're going to define constructors. This is a new pizza order. When I create a brand new pizza order, what does a new pizza order look like? We'll talk about constructors. Constructors build, and think of it, pizza order is just nothing, and then we build one with lots of room with lots of stuff. And then finally, we can write our own custom methods for pizza orders. For instance, we might want to know, given all this stuff up here, how much is pizza going to cost? That's a rule, right? How do I calculate pizza order costs, the total pizza order? That's a rule. Here's what you do. It's math. It's a rule. It goes into business class. All those calculations that we did last semester in the button calculate, gone. Doesn't mean you can't ever write a form that does button calculate again. You can. But if you're following the 3-tier model, data, business class, GUI, the calculations are all in the business class. What we're trying to do here, this is the foundation of object-oriented programming. Remember, there was procedural programming once upon a time, COBOL programs and stuff. Now we're doing object-oriented programming. We describe objects. We are now, and we're putting everything together. A pizza order has a size, and it has toppings, and it has a customer name, and we're going to store all that. Then there's things we want to do with pizza orders. So we're putting the data and the processing together in one lump. One thing. We're going to put variables in here and anything we would ever do to a pizza order. Calculate the total topping cost. Calculate the total order cost. Save it to the database. It's going to happen later. Unit 3. Validate it. Goes in here. Anything, so all the data and all the things we do to that data go into this class. In the future, somebody says, I want to be able to, I'm making stuff up here, pizza number of pies, soda. I want to change the way we select sodas. I want to recommend something. We can go to the business class and change it so that Dr. Pepper always comes up as the default. It's a rule. The default is Dr. Pepper. It's a rule. We can change it. We go to the business class. The GUI doesn't touch it. Very easy to modify. Much easier to modify. It's not always easy. I think John asked in the RDD class last hour, if I add a new field to the database, what happens? You're changing this. Guess what? This is probably going to change. And if you're going to capture that data and show it or get it from the user, you're going to have to change this. So if you make changes here, it tends to flow all the way up. But if we're just changing some of the rules, we can change them here. We don't have to change the database, don't have to change the GUI, we just put it all in here. Most of the complicated processing now goes in here. This is where the complicated stuff goes. So those are the concepts. It's an overview. A classic analogy for a business class is a cookie cutter. What we are describing here is what a pizza order looks like. It's not a pizza order, it's what a pizza order looks like. Think of a cookie cutter. I keep thinking I ought to bring one in, but my wife won't let me keep them. Bring in a cookie cutter. You going to eat that? No. A business class, you don't eat it, you don't use it directly. You define, this is what I want my cookie to look like. You define, this is what I want my pizza order to look like. And then with the cookie cutter, we go to some flattened out door, we go punch, 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 punch. And we create 1, 2, 3, 4 cookies using our cookie cutter. Using a pizza order, we can go punch, 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 and create 1, 2, 3, 4 different pizza orders. His pizza order is going to be different than his pizza order, different than his, different than hers. We can keep all 4 of them separate. They all keep the same information, right? Whose pizza? What size? What toppings? His pizza, his size, his toppings. When you use a class to create an actual pizza order, the term is instantiate. Instantiate. So now when you're making your Valentine's Day cookies, and you get out the little Cupid cookie cutter, and you go boom, 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 you're going to tell your significant other, I just instantiated 5 Cupid cookies. You don't say geek. Okay. Instantiating is a programming term. It's an object-oriented term. It's relatively new. It's only 30 years old. Relatively new programming term that means use a class to create something new. That's the classic example. Another classic example, in the old days in pizza shops, you'd walk in and they'd have this pad of paper, and on the pad of paper were all these different fields that you needed to fill out when you came in, right? What's your name? Yep. What's your phone number? Yep. You want pepperoni? Check. Mushrooms? Check. Size? Large? Check. And then they take that piece of paper, they flip it, they rip it off. You've now instantiated a pizza order. They give it to the back, and they make a real pizza out of it. This is not going to make real pizza. It's just going to make you hungry every day. Right? It's not going to make real pizzas, but it's going to document our pizza order. And then in Unit 3, we're going to take that, stuff it into a database. You've been instantiating already for 9 months or however long you've been around here with me. What's this?
Checkbox.
Checkbox. No. It's an instantiation of a checkbox. This is the checkbox. This is a pointer to a checkbox class. She wants a checkbox. Okay, cool. Bloop. Instantiation of checkbox. What's that? Another instantiation of a checkbox. It's different though, right? It looks the same, it behaves the same, it has the same behaviors. That's what the methods provide. It has the same behaviors, but it looks different because it's got a different label on it. That's all? Yeah, but we could make the label different sizes. We could change the font of one checkbox. The other checkbox still stays small. We can change colors, background color. We can do all kinds of things to these checkboxes by changing their properties. Each instantiation of a checkbox can have different properties. It's still an instantiation of a checkbox. It's just different than the one in front of it because this one's already checked. It's property. So I had my 4 instantiations of pizza orders. Each one of those is different, right? They have different properties because they all order different pizzas. What's this? It's an instantiation of a radio button, instantiation of a text box. Oh, there's another instantiation of a text box. Going to go out to your car today and start an instantiation of a Ford Taurus. Assuming you drive a Taurus. Because guess what Ford does? It has a basic template for a Taurus, right? But Rachel wants a red one. Kevin wants a white one. Kevin wants aluminum wheels. She wants cool, spinny hubcaps. I don't think they have those yet, but we get the idea. We can change the basic template. That's what we're creating here. We're defining the basic definition of a pizza order, and then later on we'll instantiate it. Going back to last class, my apologies to the couple of you who weren't there in the last class, we could instantiate a new camper because we have a template for a camper. You want a new camper? Fine, fill out this form. Save it into the record, into the database. Our business class will often very closely reflect a table in the database. Doesn't have to, but it can. Use that word instantiate in life, get used to it. Okay, how do we do this stuff? First, we define class members. And a couple new terms to add to the rest of these. Your author calls these members backing fields. It's another one of those PhD guys things, maybe from a long time ago. I don't use that term. They're called backing fields because the users of the class never see them. They're hidden. They're encapsulated. Here's my class file. You've used the text box class file, right? How does it work? You type in it, text appears, right? How does it do that? Magic. You hit the backspace key, it goes away. Magic. You paste, new stuff goes magic. How does it do that? We don't know, we don't care. We're defining our own class. For now, we care, because we're the ones that have to define what happens. Now, this class is never going to be visual. We're never going to actually see it on the form. We're going to copy out of the class onto a form, but we have to define it here. Everything we ever wanted to know is going to be inside, about pizza orders, is going to be inside this class. It's encapsulated inside there. A lot of it is hidden to the user. And we're going to talk about who the user of a class is here in just a minute. A lot of it is hidden. How does it do that? I don't know, but it does it. It has a method that allows me to calculate the total. How? I don't know. Following the business rules. What are the business rules? Well, I could go look them up. But the people who use this don't care. They assume that your class works. We encapsulate. We hide stuff. We're going to have members inside of our class that nobody's ever going to see because we only need them to do the work of the class inside. They're hidden. One other point I want to make, because I'm about into your lab time here. We'll do a couple members real quick and then we'll be done. One other point I want to make. Who uses a class? A human like somebody at Lions Camp who's typing in data? No. The class is a programming tool. Programmers use it. Other programmers use it. We used the text box class as programmers, right? We dragged a text box. We instantiated a text box. So we're dragging. You instantiated a text box which used the class that's behind the scenes that we don't even see, so that our user can use the text box, type in it. But we, the programmer, had to put it on the form first. The user of a class is a programmer. Or another way to look at it, another program. This program needs to process pizza orders somehow. Okay, great, I need this pizza order class. Let me have that. The user never sees it. We'll review those next time. Whew, look at all that stuff. Let's put a few of those in as members for every piece of data that you want to capture about a pizza order. And I don't have them all here. I'm simplifying my pizza orders just like I simplified my subs, so that it doesn't take forever to do this. Again, not real world. You want it real world, work with it. Here's what we're going to capture. So we need data members for all of this stuff. When you define data members, the first thing you say is it's private. That means the user of this class does not have direct access to it. I thought you said that was a programmer. Programmer can't get to the employee name. Not directly. Indirectly through the properties. We'll do properties next time. Steve's confused. Good. No, not good. All right. That's okay. It's a brand new concept. Brand new concept. So let's build one of these. Inside here, first thing I do is put in some comments. Members. And then I define that they're private. All of your members are private. There are exceptions, not in this class. All members are private. Remember we did that with our constants? I required that you make them all private. That means only this form can use them. Only people inside of this class can use the members directly. Then, like everything else, what type? If I'm doing the customer, or order date, sorry. Order date is first. What type is it? It's a date time, just like last semester. These members are typically the types that you're used to. Strings, ints, doubles, booleans, date times. They can be some of the other things, but again, that's beyond the scope of this course. The date time. What do we want to call it? Underscore order date. We haven't done underscores before. Remember, they're legal. I remember all the way back to your first worksheet. What's a variable name look like? Could start with a letter, but it can also start with an underscore. There's a reason for the underscore. Let me explain it to you next time. And then this is like Volker says, it's like a variable, so we better describe it. The date this order was placed. Because remember, he's got an order, and he's got an order, and he's got an order. I need some place to store for that order. What date was it? Our standards say every member gets a description, just like every variable gets a description. And I need another private member. This one's a string. For the customer first name. Now in my notes over there in red, they're not camel case. It's all right, we're good C# programmers, we'll adapt. And this is the first name of the customer who placed the order. You can get as elaborate as you want here. I couldn't believe it. Yesterday in my systems implementation class, we were talking about Lions Camp, and they said, we got to make sure we document the heck out of this stuff. Because when we're done, there's 15 of them. When we're done, we're going to turn it all over to Volker. And I can change your grades anytime, even 5 years from now. So if you don't document well, I told them, I said, we're going to document. This stuff starts becoming important to you.
So what's the difference between a teal string and a blue string?
Blue is primitive type. And this is a built-in class. Date time is a class. Notice pizza order, that's my class. It's not built in, but it's now going to be defined.
Here's a string that's also
Teal.
color, right?
Capital S. Is that what I've been telling you to use? I don't think so. That one's a little harder to use, that's why we don't use it. It is a class that can do other things to strings that we're not used to, that we don't need.
So it's
We'll stick with the basic string.
For now.
For now. All right, let's do 2 more for today. We'll finish the rest next time. So I have to review anyways. So we also need the customer last name, and we'll skip the comments for now since you're following along, but I would comment every single one of these. What am I planning to put in here? And then finally, private, I need the size of the pizza. What type is that? Pardon me? Integer? Depends on your perspective, right? Does that mean 10 inch, 12 inch, 16 inch? Or does that mean small, medium, large? Small, medium, large. So you're asking me. Right? If you're not sure, you ask the owner. What's it in it? Remember, normally we have a database, right? We already have a database, normally. What is it in the database? It's a string. Okay. It's a string here. They have to correlate. Otherwise, I can't take an integer here, stuff it into a string over there. I can, but it's a pain. We're not going to do that. Size. Save it. Let's stop there. When we come back on Tuesday, we'll review. I'll remind you again of the important word instantiate and what it means, because it shows up all over the place, and I use it a lot. I don't usually use it when I'm making cookies, but it gets used in programming, instantiation, and we will instantiate this pizza order. And if we wanted to, we can instantiate a lot of them. And we could have in our program at any given time 5, 6, 10, 100 pizza orders. The more we have, the more memory we take. So I don't always have a lot, but you can. But what we're doing here is a final review is encapsulating everything about a pizza order. What properties does it have? It has a size, it has a date, it has a customer first name. And what kind of things do we do to pizza orders? We calculate totals, we calculate topping costs. For us, that's about it. But some classes have dozens, hundreds of methods, things you can do to them. This is a class, right? Date time. What can you do to a date?
Change.
Change it to something else, format it. Add 3 to it. Remember the add days 3? You can add days to it. I can subtract days from. I can do things. That class knows how to add days to a date. If you ask it right. If you add, you have to say add days, right? You can't just say plus days or days minus, or you got to ask it right. You have to use its methods. And we're putting all that into one handy dandy container that's reusable. Oh my God, here we go back to systems again. It's reusable. I could make this pizza class for Little Caesars, and then Domino's calls me and says, can you make us an app? Sure. I could probably reuse this with some tweaks for Domino's because their pizzas have sizes and they have customers and they have dates and same stuff. So I could potentially reuse it. Enough. Got an hour. Lab will be around to help you with that. If you're not working on your assignment tracker, you'll probably be sorry later. Should be applying the standard dialog boxes to your assignment tracker. Your assignment tracker should be able to read files, write files. Pretty soon. If you're still working on the lab, I'd be glad to help you.
I'm gonna go try